to get started. Good morning, everyone. The time is now 11 o'clock. My name is Dr. Ramonsenga Pleki, and I'm a researcher at the Agricultural Research Council, Institute for Natural Resources and Engineering based in Pretoria. Before we get started with the talks, I would like to tell you a bit more about our national assets here at ARC. So the Agricultural Research Council is a custodian of a large portfolio of national assets. A national asset is defined as a resource of economic value and permanent value belonging to a country. The different campuses of the ARC are over 100 years old and have maintained these national assets, giving testimony for the organization's ability to continue to do so for now and in the future. Also, the ARC is a national asset by virtue of its collection of expertise, infrastructure, experience, service, and people. Through these assets by the ARC, it has been able to support research and development efforts across the continent and beyond, and thus making South Africa's agricultural sector one of the best performing agricultural sector on the continent and globally. And speaking to the theme of this year's Science Week, which is celebrating the role of basic science in the modern world, we have an amazing lineup of speakers. Who I'll introduce to you just in a few minutes. And to all the participants, you are most welcome to post your questions in the chat room, and I will also encourage our speakers to engage with you there. However, each speaker will have 8 minutes for presentation and 2 minutes for questions. And also please do note that this session is being recorded. So just to introduce our first speaker, so I'm going to stop sharing my slide on national assets, which just gave you an idea of those assets that we do have. And now to introduce our first speaker, who is Mrs. Makgabo Matlou, a researcher at the ARC NRE, and a position she's held since 2006. And prior to joining the ARC, she worked as a part-time technical staff at the university. She's also a member of various scientific bodies and is a registered professional natural scientist. She's involved in implementing various government programs, mainly specializing in soil science, sustainable agriculture, climate smart agriculture, rural development, food security, agro-processing, and action research. And the title of her talk is Soil, is it just a medium for plant growth? Over to you, Mrs. Makgabo.
Good morning, ladies and gentlemen. Can you hear me?
Yes, we can hear you.
Okay. The title of my presentation is Soil, is it just a medium for plant growth? And the answer to that question is no. Although more than 90% of plants grow in the soil, soil is more than just a medium for plant growth. I will tell you about the functions of the soil in the next slides. The outline of my presentation is as follows. I will tell you about the definition of soil, the functions of soil, why do we protect soils, and career opportunities in soil science. Soil is a loose surface material that covers most lands, is a natural material from weathering of rocks and decomposition of organic matter. Is comprised of about 45% mineral particles, 25% air, 25% water, and 5% organic matter. For those, if you want to test if soil contains air, you can add about 200 grams of soil in a 500 ml container, and then you add water to dry soil, and then you add water to that, then you will see bubbles coming up. If you look at the soil profile, which is a vertical section of the soil, look at from the topsoil to the hard rock, you'll see something with the layers like this. We do have a horizon, the B horizon, and C horizon. And then each and every soil profile tells you a story. Like, for example, if you look at the red soil here, the red soil profile with uniform color, the soil is deep. The red soil comes from oxidized iron, and the agricultural potential there is of the soil profile is very high, because the soil, if you look at the structure, the texture, and the fact that the soil is very deep, it means the agricultural potential is very high. But then if you look at the soil profile like this one, the other one with the shallow, where the soil profile is very shallow, the profile is comprised of just the AU horizon and the hard rock. The agricultural potential is very low, meaning you can grow fewer crops with shallow root system. For deep-rooted crops, you can't grow them in a soil profile which is very shallow like this. Otherwise, the yield is going to be very low. The functions of soil, it anchors plant roots, and it also provides nutrients to plants, and then it stores organic carbon. Normally, people encourage growing of plants so that they can absorb carbon to undergo the process of photosynthesis. So normally, we, at the Agricultural Research Council, we encourage farmers to protect the soil. Instead of plowing the soil using the motorball plow, we encourage farmers to only plow where they are going to plant, so that the organic carbon can be stored in the soil instead of being released into the atmosphere, contributing to the climate change, the negative impact of climate change. We also get food and other biomass from the soil. We build roads and houses on the soil, and you also get other raw materials like platinum, copper, gold. You mine it from the soil, and then soil can also be used as a cultural heritage. Like you see the Himba women, they mix certain types of soil with butter and then apply it to their bodies. And in some cases, especially in KZN and Gauteng, you see women mixing soils with water and use it as a sunscreen. Why do we protect the soil? It takes many years for a centimeter of soil to form, about 400 to 500 years. About 12 to 14% of 16.7 million hectare of land is rated as suitable for dry land production in South Africa. However, out of that 12 to 14%, we have 3% of that has high agricultural potential. By that I mean the soil quality indicators are higher. Like, for example, you find that the soil depth is very high. It has deep. The soil depth is very high. It doesn't have a shallow soil profile. They don't have soil profile. And then some of these pictures here are very familiar. This one, the middle one, was taken in the Eastern Cape, where there are so many dongas. And then it has been estimated that about 3 tons of soil is lost for every ton of maize produced, especially if in cropping fields where conventional tillage is being practiced. Conventional tillage is where you plow the soil, you loosen the soil, and then when it rains or if there is wind, most of that soil is being lost. And then how do we protect the soil? We can move from conventional tillage to conservation agriculture, or where we protect our soil is either through intercropping. Like, for example, here we intercropped maize with the legume crop. The soil, the ground cover is covered. The soil is covered. That protects the soil from erosion, prevents root growth, and then it also improves soil quality. Even here with the mulch or even the crop residues, at the end of the growing season when harvesting, you take whatever that you need, and then the crop residues are left in the field. Career opportunities in soil science, one can study towards Bachelor of Science in Agriculture, majoring in soil science. You can be a technician, a lecturer, or a researcher, or if you are a researcher, you can choose an area of specialty. So you can be a pedologist. Pedologists deal with the classification and mapping of soils. They do conduct the soil survey, or you can be a soil biologist, where you focus on the microbial or faunal activity in the soil, or an agronomist, which they focus on soil and crop productivity, or you can be a soil physicist, which deals that's a soil scientist who specializes in the phases such as solid and liquid and gases in the soil. Thank you so much.
Okay, thank you so much, ma'am, for that interesting talk. Please switch on your camera so that we can see you. I think you forgot to do that. We have about to do that. We have about to do that. We have about to do that. And please mute your mic. We have about 3 minutes for questions, and I'll take a few hands for that. Any questions for Mrs. Makgabo Matlou? Okay, so I think I have one question for you, ma'am. Over time, would you say the soil quality or the soil that has agricultural potential in South Africa, is it deteriorating? Yes. Or it's still the same as maybe 20 years ago? And yes, yeah, that's my question.
Thank you for the question. The soil quality has deteriorated, hence the government has introduced various policies, frameworks, and piece of legislation to try and protect the soil. It has been reported that worldwide, or even in South Africa, we are left with some researchers estimate that we are left with 60, some even say 30 seasons, because most of our soil is being eroded. People use unsustainable farming practices when they are farming in their cropping fields. As a result, most of our soils is being lost. Recently, in KZN, during the recent floods, there were newspaper articles that were talking about climate change and the geology. One, I think it was one newspaper in particular, I think it was Daily Maverick. They wrote an article saying in some cases, in some areas, some of the soil was eroded because the people replaced ground cover like lawns and flowers with pavements. So when it rains, most of the water just flows quickly, and then or in some cases the soil is exposed. So most of the soil is being eroded that way. So the soil quality has decreased. Even among the small scale farmers, they use unsustainable farming practices. In some cases, they even burn the crop residues. They allow the animals to go into the fields after harvesting. They compact the soil. They eat the fertilizers. So thank you.
Okay, thank you, ma'am. So if there are more questions, please post them in the chat room. Now we have to move to the second speaker, is Dr. Sarah. If you have a question, you can please put it in the chat, and Mrs. Matlou will reply there. Moving on to the second speaker, is Mrs. Krishna Henningser. She has an MSc Meteorology degree from the University of Pretoria and is the quality manager of the Acromet, quality control manager of the Acromet weather station network, consisting of over 600 weather stations spread across South Africa. She's also part of the Acromet division in the ERC NRE and is situated in Bethlehem. And the title of the talk is Climate versus Weather and Other Weather Questions. Over to you, ma'am.
Good morning. So this is a very basic, quick presentation. Thank you for having me. The first question we are considering is climate versus weather, and then we're going to touch on a very few other weather questions. Now, climate and weather all very often get misused. So what is the difference between weather and climate? Weather is a short time phenomenon. So it's basically the difference is just the time. Weather changes within a few minutes or a few hours. If you look at the mornings where the sun is shining and then suddenly in the afternoon it's raining and before it gets dark the sun is shining again, that we consider as weather. It changes very quickly within a few minutes, few hours. Like they say, if you don't like the weather, wait 5 minutes, it will change. Climate, on the other hand, takes a very long time to change. Climate also gets classified into classifications like tropical or subtropical or polar climate. It takes a long time to change. The pole's climate is not going to change suddenly to tropical in a matter of a day or a month. It takes very many years for the climate to change. Another question we are considering today is what are clouds and rain? A cloud is made up of very tiny droplets of water or ice crystals that are so small that they can float in the air. Now, how do they form? Basically, it's very easy. The sun warms the surface, warm moist air rises up to the point where the air expands and cools down, and then it condenses into water droplets. And many water droplets form clouds for us. A practical example of this is looking when you boil a pot of water on the stove. Then the steam that rises up from that pot can be considered a cloud because it is airborne droplets. How does rain form? In the cloud, the droplets bang together. Now, again, if you go back to your kitchen and look at that pot of boiling water, if you put the lid on top, those droplets are going to bang together and they are going to run down that pot lid and fall down as droplets. That can be considered rain if we want to be technical about it. So in the clouds, the raindrops bang together, and when they are big enough, then gravity takes over and they fall to earth as rain. Now we get rainstorms and we get thunderstorms. And in big storms, we often have lightning. And you must remember, lightning are all very dangerous. It doesn't matter if it's cloud-to-cloud lightning, like in here, or if it's cloud-to-ground lightning. All lightning are dangerous. And whenever there's a lightning storm, never ever hide under a tree, because lightning likes striking trees. And when you're under that tree, that lightning is going to strike you as well. Another question is, how do we measure weather? We use weather stations. Now, in the olden days, we had to make use of weather observers. Now, a weather observer has to run in from his little house here to the weather station setup, and he has to go to each of these elements to measure the weather. I'm quickly going to show you what all these elements are. We have over there the sun hour measure. It's a crystal ball, if you want to believe me. It's a glass ball that literally burns sunshine hours into a piece of paper. The observer must change that paper every day. There we have a rain gauge. It has a tin on the inside that captures the rain as it falls, and he has to measure it in a measuring cup to say how much it rained. So this is called the wind run. It has numbers on it that the weather observer must write down. This is an APAN. It measures evaporation. He must make sure that that pan is full, and then every day measure how much of the water evaporated in that day. This is called the Stevenson screen, and inside of the Stevenson screen, we have a thermohygrograph that measures temperature and humidity, and then also thermometers, wet and dry bulb thermometers, and the weather observer must change this every day to make sure and write down the observations every day. That means that poor guy cannot go on holiday. He's not allowed to get sick because 8 o'clock every morning he has to run out and come do all of this to make sure that the weather gets measured accurately. Now in the new world, we use automatic weather stations. They look like this. They have a rain gauge. That rain gauge has a bucket inside and a switch that counts out how many times that bucket flips, and the water runs out at the bottom. So no need for a person to measure that rain. There we have wind speed and direction. That is also measured automatically. A solar panel to keep everything going. And in there we have these little, that looks like a stack of sources, is in place of that big Stevenson screen we had at the mechanical weather stations. In there we measure temperature and relative humidity with only one small sensor, and on top of it we have a radiation sensor. So unfortunately we don't stare into crystal balls anymore. Inside the weather station box we have a data logger that is like a computer that saves all the data that is collected from the different sensors. We have a regulator and battery setup that's connected to the solar panel to keep everything going. And of course, we need to communicate with the weather station, and there is also a logger and an antenna for us to communicate with these weather stations. So why is it important for us to measure weather and to know what's going on in weather? If we understand the weather and climate, we can plan for the future. We can plan for climate change. We can plan for basically anything that we have coming at us. If we understand the weather, we can plan for it. Also, if we can measure the weather, we can make decisions to make our life better. For instance, farmers use rainfall measurements and rainfall numbers to plan their irrigation. If it hasn't rained in a little while, they give their plants water with irrigation. If it rained yesterday, obviously they don't need to water their plants today. Also, just on a little personal note, if we know what the weather is going to do, we will know how to bring an umbrella so that we don't get wet on our way home this afternoon. Thank you very much for your time.
Thank you very much, ma'am, for that interesting talk. I hope we've all remembered to check the weather this morning so that we don't get rained on. We have 2 minutes, just 2 minutes for questions. And I see a few hands already. I think the first one is Chimangazo. Please go ahead. Ask your question. Okay, Chimangazo, are you there? If not, then we'll go to the next question. Do we... Another hand. Please unmute and ask your question. Unmute your mic and ask the question.
Hello.
Yes, we can hear you now. Go ahead.
Okay. Thank you for an interesting presentation. I have a question with regards to the automatic weather stations, how often do we need to maintain them, and what kind of maintenance is needed for them to keep running?
Thank you. That is a brilliant question. We aim to visit the weather stations at least twice a year. Of course, there are all kinds of things that might prevent us from doing it. So if we do it once or twice a year, then we can keep them in a relatively good way. We send people out there with a calibrated calibration kit, and then we check the weather data from that calibrated kit against the weather of the weather station. Basically, we're putting a mobile weather station right next to it, and we're checking that the values are similar, and if necessary, then we replace or adjust the sensors as necessary. Also, my job actually is to look at the data that we collect every day from the weather stations and to pick up errors if there are errors, and then to send out the guys more urgently than once every 6 months if there's a problem with the weather station, to fix it if they can, otherwise to replace the sensor.
Thank you so much, ma'am. Please, everyone, keep engaging in the chat room, posting your questions there. Let's keep the discussions going. And the third speaker is Dr. Lerato Matsaonyane, and she has been in the agricultural industry for 20 years, where she tackled molecular biology, crop protection, agriculture extension, and education. Her molecular biology research entailed identification and characterization of antifungal genes, cloning genes of interest into plants to improve traits, characterization of genetically modified crops, and identification of drought-tolerant genes in crop. She has collaborated with the Northwest and Northern Cape Provincial Departments of Education on assisting grade 11 to 12 educators and learners with the concept of genetics of the agricultural science cap subject. And today she will give a presentation entitled, "There's a veggie on my stoop." Take it away, Doc. Thank you. Please unmute your microphone.
Yes. Thank you very much. Am I audible?
Yes, clear.
Oh, let me just upload the presentation. Is the presentation visible to everyone?
We could see it before. Maybe if you, yes, we can see it now. Just put it in the presentation mode. Yes, everything is in order. Thank you.
Thank you very much. Good morning, ladies and gentlemen, and thank you very much for joining us on this webinar as part of the National Science Week. Ms. Matlo has set the platform when she explained to us about soil and soil characteristics, and Ms. Hieningsa also continued with setting the platform that I need when she explained or shared more information on the climate of weather. Now, what I'm going to go into is how we can now utilize the soil and the weather, the rain, etc., to make something that we need on a daily basis, which is food. Statistics have shown that around 80%, in some instances, around 80% of the total household income is spent on food, and this food is sourced from markets. Some is through exchanges, and others are from public food programs. Now, with this information, it has also shown that in a lot of instances, the notion is that you get food insecurity mostly in the rural areas, but it has been found that in the urban areas, there is what is known as the urban poor, and these individuals or households have been found to be food insecure because of the high amount of money that is spent on food. That is what I mentioned earlier, 80%. So now the question that one asks is, why are we not doing something about this? And as some philosophers said, if you grow your own food, it's simply equivalent to one printing their own money. Somebody might ask, how do we do this? So this is what this presentation is about. If you look at the picture that's on your left, it is an example of a homemade vertical farming structure. All you need is PVC pipes. If you go to your local hardware store, you get PVC pipes, you get the joints, you make several holes and you put your seedlings there and you make sure that there's sufficient water to irrigate. And there you have your vegetable in PVC pipes. If you want to go simpler, the picture that is in the middle, you can use empty soft drink bottles. You cut them, you can stack them up to make something equivalent to the vertical structure on your left. You cut them up, you fill them up with soil, you put holes, you poke holes on the bottles and you insert your seedlings there. And you make sure that at the top you have some of these bottles filled with water, and through gravity the water will seep through the different layers, and you have your vegetables growing in such a contraption. If you have a bit of land, you can still go to your hardware store, get a few poles and net similar to the structure that is shown there, and you can produce on your land, covered under shade netting, especially trying to keep away birds that normally damage your spinaches. Taking it to another level, you can also look into, your 12.5 bags of mealie meal. When the family has finished enjoying the mealie meal, you can take that bag, make holes on it and fill it up with soil, take your seedlings and plant them on that bag. You can have instances whereby you don't plant just one type of vegetable, you can plant multiple vegetables, but obviously you will need to know the type of vegetables to plant in such a system, because you need to make sure that there is no excessive competition between the vegetables. Going back to the 2-liter bottles of fizzy drinks, you can also plant in them where you can cut holes in that, fill it up with soil, and you have your vegetables right on your stoop. Taking it to another level, there are farmers that have successfully fed their families and also made significant profit from planting in tires. We know in our communities, as soon as your vehicles, the tread of your vehicles, tires has gone, they replace the tires, but the tires start stacking up at home. So you can use this as part of your veggie gardens in your household. What I'm sharing with the participants today, it's not some pipe dream or something that was just done in the lab or research that was done somewhere else. It's something that I've also started doing as somebody that loves money. So I'm printing my own money by having my own vegetables. So the picture on your left is where the vegetable production started, where I took a bit of soil and you plant some seeds and you constantly monitor the soil moisture to make sure that you do not starve the seeds. And as soon as the seedlings started emerging, you transplant them to the soil. And I think for the past 2 months, I have been enjoying delicious potatoes from my own garden. And at the Agricultural Research Council, we practice what we preach. So this is just an example of some of the land that's available next to the buildings where we've planted Swiss chards and a couple of other vegetables. So we do practice what we preach. So somebody might ask, in the previous pictures, I showed the shade net whereby you can plant your vegetables under the shade net to keep away some unwanted predators on it. Somebody might ask then, what happens when some of these I cannot afford a shade net, but I have a bit of ground to plant on. What happens if I want to protect my plants and want to keep away from using chemicals? Fortunately, there's been extensive research that has been done, and a simple concoction whereby one mixes chilies and garlic, you let them seep overnight in water, and you strain and you take the solution and you spray on your vegetable production, you are able to keep away a significant amount of pests, as well as control some of the diseases. Some research has shown that you can use your normal dishwashing liquid. Some research has shown that you can also use vegetable oil to control insects on your production patch. In some instances, there are people that have successfully used, and it has been researched as well. There have been instances whereby you can use ash from after burning a fire, you can use that to control insects around your production area. Looking at the garlic and chilies and dishwashing liquid, white might think that no, this is something that is just fabricated, but I'm one of those researchers that has done research on this. And if you look at the picture A, this is a typical structure of a bacteria which causes disease known as Burkholderia. In picture B, this is these three pictures that you're seeing in front of you. These were done under a light microscope. So in picture B, we treated the bacteria with the chilies and garlic concoction that I mentioned earlier, and you can see the blotches that you see on these pictures depict the disruption of the bacterial cells. And in picture C, we did the chilies garlic concoction and added the dishwashing liquid, and you can see the flattening of the bacteria, showing disruption of the bacteria cells. So this is just to prove in a lab setting that these concoctions do really work. So the last thing that I'll leave you with is that, would you rather see yourself going to the market, going to the retail stores and spending between 60 and 80% of your hard-earned cash in procuring food, or would you rather have something in your hand, that being a vegetable patch in your garden? Thank you very much.
Thank you very much, Doc. I think we can take one quick question. If there is any, one quick question. Okay, if you have questions, please post them in the chat so that Dr. Lerato Matsonyan can respond to them there. Moving on to our fourth speaker is Dr. Ngobile Masondo, a senior researcher at ARC. Okay. A senior researcher at ARC VIMP. Her research focuses on agro-processing and product development of various dietary supplements, herbal and cosmetic products from indigenous vegetables, medicinal plants, and industrial crops. The agro-processing lab she manages looks at enterprise development for small, medium, and micro enterprises, such as indigenous knowledge from holders. Dr. Masondo will present to us a topic entitled Application of Medicinal Plants in Traditional and Modern Medicine. Doctor, please switch on your camera and share your slides, please, on the screen. Thank you.
Good afternoon, everyone. Can you hear me?
Yes, perfectly.
Okay, is my screen on slide mode, my presentation?
Yes, it is.
Okay. Good afternoon, everyone. So as I've been introduced, I'll be speaking on the application of medicinal plants in traditional and modern medicine. So in this presentation, I'll give a brief background of medicinal plant history and their current status in the market. Sorry about that. Just want to move some few things here. So African medicinal plants. So our African continent is believed to be the cradle of humankind. And just a quick one here. I'm just trying to sort out some few things. Just apologies for that. Just want to quickly unshare and share again the screen. Is my screen shared?
Yes, yes, it is.
Okay, thank you so much. So the African continent is believed to be the cradle of humankind, and its use of traditional medicine is also believed to be one of the oldest and most diverse therapeutic systems. So the continent has a long history of healing art that dates back to 3200 BC in the ancient Egypt. The ancient African healers used mixtures of various herbs, animal parts, minerals, and clay. And the use of medicinal plants was the most common practice in Africa. And because of this, it is because Africa has a very biodiverse flora. And it has more than 5,000 medicinal plants that are used for health benefits. So the use of traditional medicine is still a common practice even in the 21st century for majority of the African population. And according to the World Health Organization, it is assumed that about 80% of the African population is still reliant on traditional medicine for their healthcare needs. The reliance on traditional medicine has generated a multi-billion a multi-billion rand industry in South Africa. And these plants are harvested from the wild and sold in the streets by the healers, or unfortunately, people that might have limited knowledge of the medicinal plants. So these medicinal plants are sold as dried material, ground powder, or prepared as concoctions. Over the years, we have seen a change in our traditional medicinal plant industry, from plants being sold as crude or unprocessed products to now being marketed as herbal supplements that are processed into capsules, tablets, or ointments. Interestingly enough, some of the bioactive compounds in medicinal plants are now produced as prescription drugs, which contain purified ingredients that is regulated by the SAHPRA in South Africa. For example, we've got morphine, a common common drug that is used to treat moderate or severe pain. The extent of the medicinal plant benefits has been observed in a relatively new booming industry of nutraceuticals. So nutraceuticals are defined as food or part of a food that provides medicinal or health benefits, including the prevention or the treatment of a disease. They are classified into dietary supplements, functional food, and personal care. So nutraceuticals may be used to improve one's health. They delay aging processes, prevent chronic diseases, increase life expectancy, or they just support the structure or function of the body. While in the past, dietary supplements mostly contained specific vitamins or minerals, but now these dietary supplements can contain one or more plants, either vegetables, fruits, protein-based crops, or medicinal plants. And also some of the food is now being fortified not only with these vegetables or protein-based crops, but now one can use medicinal plants. For instance, you can see there's a marula and raisin rusk that recently came to a SPAR outlet. So the dietary supplement market is expected to show an accelerated growth rate from $123 billion market size to an expected $288 billion market size by 2030. There's a number of factors that is driving this accelerated growth, which include the demand for sports nutritional supplements, the healthcare and wellness, the prevalence of chronic diseases and disorders, and the need for a balanced diet. So if we look at the case of moringa, a widely used medicinal plant globally at this point, its market value was valued at over 1.3 billion US dollars in 2021. And now it is expected that the market will reach a value of 2.9 billion US dollars by 2031. However, Africa and the Middle East are the least contributors to the moringa supplement market. We can see there with the red arrow that show just the growth rates of the market for the Middle East and Africa relative to Europe with the gray bar, and North America with that bluish bar. So another industry that has shown a potential accelerated growth is the cosmeceutical industry. Cosmeceuticals are defined as products that incorporate biologically active products with medicinal or drug-like benefits that is intended for topical application and the mucous membrane of the oral cavity. So the market trajectory for the industry has shown an increase gains over the years, with the personal care product market valued at 18 billion US dollars in 2021 and is expected to reach a height of $40 billion by US dollars by 2029. So some of the factors that are driving the growth the growth in this market include the rising awareness of skincare routine, the innovative product branding, and advertising strategies. So now in this table, we did some online searches for South African branded cosmeceutical products that are formulated from indigenous medicinal plants by our own South African SMMEs. We found quite a number of these products developed for skincare, hair care, and cleansing products. Since these products are sold online and in the South African market, there are some products, though, that are even sold internationally due to the benefits of online shopping. This might be a start to South Africa contributing already formulated products instead of exporting raw and unprocessed medicinal plants internationally that are ones that when they're developed, then they cost South Africans exorbitant amount of funds. So our take-home message that I'll bring to the audience is, from now on, I would like us to see medicinal plants beyond the plants that are sold in the so-called black markets, but as an opportunity and a form of income generation for South Africa and other African countries. We need to start making our own products that with time are able to compete with big brands like your L'Oreal, your Nivea, your Clinique, and your Garnier. So this can only be achieved if Africa develops their own products and they're able to generate IPs and patents. So with that, I'd like to end my presentation here. Thank you.
Thank you so much, Doctor. We've learned a lot from your presentation. For the sake of time, I would ask that we move to the last presenter. However, everybody, please continue engaging in the chat room, posting your questions there for Dr. Masondo as well. So our last speaker is Prof. Stephen Amu, a principal researcher in the ARC based on vegetables Industrial and Medicinal Plants Campus in Roodeplaat, Pretoria, conducting research on indigenous crop and medicinal plants. He is an NRF-rated researcher and serves on the editorial boards of several international scientific journals. He's the author or co-author of more than 100 peer-reviewed scientific publications and book chapters, and more than 70 national and international scientific conferences. Additionally, he has successfully mentored postdoctoral fellows and supervised more than 100 postgraduate students to completion at PhD and master's level. And his talk is entitled Going Back to Our Roots, Unlocking African Leafy Vegetables Potential. Over to you, Prof.
Thank you very much, the chair. Thank you very much for the introduction, and distinguished guests. Good morning, everyone. Yes, we need to go back to our roots. What do I mean by our root? Maybe let's begin with the statistics. What does the statistic tell us? Okay, yeah. If we look at World Hunger Statistics, perhaps you might be familiar with this report. 1 in 9, as of 2019, 1 in 9 go to bed on an empty stomach each night. Think of it. If you go to bed on an empty stomach, the chances you wake up very hungry the following morning. And then to worsen it, 1 in 3 suffer from some form of malnutrition. This was 2019, and imagine this was pre-COVID. And then if we fast forward a little bit, the hunger map as at 2021, based on the FAO report, 2019 to 2021, this is the hunger map that you can see on your screen. And if you look at that screen, the darker the color of that part of the map, the more prevalent the problem. So when we look at hunger map, if you look at African continent compared to some other continents, does it not smell, does it not indicate that there is a problem in Africa? Okay, if we move forward again, if we look at the food insecurity map, again, the darker the color, the more the prevalence of the problem. When you look at African map as well, you see that there is a real problem presented according to that statistic. Yes, African has a problem related to food security, related to hunger, and I believe African problem requires African solution. No one is going to solve African problem for Africans. We need to look inward. And so one of the strategies that has been promoted or advocated for combating food insecurity as well as problem of hunger is the promotion of fruit and vegetable consumption around the world. No wonder 2021, last year, was tagged by the FAO as the International Year of Fruit and Vegetables. So last year, how many fruit and vegetables did you consume? And this year, how many have you consumed? Perhaps you are familiar with these particular vegetables. Swiss chard on the left-hand side. Some people often call it spinach. Yes, some of us hardly does a week pass without eating on this one in various forms, no matter the recipe. And what about the one on the right-hand side, cabbage? Yes, maybe in your coleslaw, you eat it almost every week, if not on a more frequent basis. What about these vegetables? Yes, do you know any of them? Amaranth, cocorus, some of the local names are also put in brackets there. Have you eaten any of them before? How do you feel looking at them? Are you proud to even eat them? Or do you associate them as a poor man's food, which is the stigma that some of these vegetables carry, or considered as weed? Yes, people consider them as weed, and some people who are raised with this, when they come to urban areas, they feel like, no, we were raised because we were poor, so we don't want to eat it. Okay, this presentation is to highlight that these African leafy vegetables, they've got nutritional values that want our reconsideration. A closer look at them will convince you that we actually need to value what belongs to Africa. Yes, African solution to African problems. The African leafy vegetables have been proven by the research conducted that they are rich sources of vitamins, calcium, zinc, and iron. They have a lot of medicinal properties, and most importantly, they are part of the culinary tradition of our local people. We grew up, some of us, we grew up with this. And so why are they not in the formal market? Why? It's a question that we all need to find answers to. If you look at some of the research indicators we have here, this graph shows when we did a comparison of Swiss chard or spinach with the cabbage, as well as one of our African leafy vegetables, that is cleome. You notice cleome has got more nutritious value than some of these commonly consumed vegetables. If you look at the phosphorus content, if you look at the potassium content, calcium content, iron and zinc are especially macronutrient that for which Africa is struggling with the deficiency. And when we look at the data, of course, cleome supersede in terms of the content compared to some of these commonly consumed vegetables. And if you look at some other ones that are not even highlighted in the arrow here, you'll notice that, of course, they compare favorably. They are not the, cleome is not the least of when we compare some of these nutritious value of it. And then we went further to also look at the antioxidant activity of it. A comparison showed that it's even the highest when compared to Swiss chard as well as cabbage. Of course, we know the production method and some other factors can influence the nutritious value as well as the antioxidant activity of this. But the point is that this African vegetable, we just use cleome just as an example to indicate that they can be more nutritious than what we think. And so in terms of other attractive characteristics of this crop, they are able to grow on low fertility soil, the so-called marginal soils. They have high relative drought tolerance. They have fast growth rate. No wonder they grow widely as wheat. Yes, they require low production input. And they are mostly collected from the field because they easily grow everywhere. They are seldom cultivated. Yes, they've got potential to be developed further into niche crops. No wonder they found potential in product development. These are some of the products that you find on the market. This one is packaged by a company. They label it as Imoya food. What does it contain? Basically, leaf powder of amaranth. And in fact, in the label, they mentioned that it can be used in smoothies. Yes, there have been cases where people use it in smoothies, in shakes, in soups, and in stews. More than that, in ARC, we've also developed product from some of these African leafy vegetables. For instance, on your left-hand side, you see the one that is branded as Nala Morocco bread. This is basically making use of grain amaranth, the grains from amaranth, the seed, to make that product. And that is a gluten-free food. So it's actually a niche product. What about incorporating it into a cake? The one you see in the middle, this is another product that was developed here in ARC. We've also seen so many other products, jams, into packaging it into capsules in form of nutraceuticals, making it into noodles, the one that was done in collaboration with some stakeholders where you have 2-minute noodles with Morocco. And then you also have the one that is in form of porridge. You see on the right-hand side, pure. So the sky is the limit as to the amount of product that can come from this. We need to start valuing what we have. We've looked at one of the critical factors that can make or mar the product from this crop is the sustainable production. You need to have it sustainably produced so that you can have regular raw materials for this product. And no wonder ARC conducted commercial trials on some of these leafy vegetables. The picture you see here is the one of amaranth, for example. So what is the take-home message from this? Please, when you see African leafy vegetables the next time, consider them as highly nutritious. They are not poor man's food as people think. If they were poor man's food, how come that we grew up with it? And of course, we were raised with it and we didn't really suffer so much like that as people would think. Yes, they are highly nutritious as research indicators have shown. They can provide necessary micronutrients, phytochemicals, and vitamins that are needed to counteract malnutrition problems. They can be developed into inexpensive superfood as illustrated with some of those pictures. And then they can form component of diversified healthy diet and food diversification program. And so I leave you with this final thought. Africa is known as a diversity-rich continent, including our rich white vegetables. Yet, Africa is often pictured as an undernourished continent with food insecurity problem. Is that not a paradox? Shouldn't we go back to our roots and value what we have and develop it further, finding African problem for Africans, finding African solution to African problem. Thank you.
Thank you so much, Prof. Unfortunately, we don't have any time left for questions. And in closing, I would like to thank all of the speakers for your interesting presentation, which we have learned a lot from, and to all participants for your active engagement. A special thanks to Ms. Adri and her team for organizing this webinar. And if you have any questions or query, please contact Adri. Thank you so much, everybody, and take good care. Goodbye. Oh, okay. I think I see one hand. Not sure if you can. Yeah, I'm still left with a minute. So please go ahead, Mrs. Marco.
No, I erroneously pressed the icon. I erroneously pressed the icon. Thanks. Bye.
Okay. Thank you. Have a good day, everyone.
Bye.